I welcome you to the Impact Summit. My name is Gabriel Meyer, and I will talk about condition-based maintenance in smart cities with a Raven IoT sensor box solution. Let me introduce myself. I'm the Marketing Segment Manager Smart Industry at Avnet, based in Munich. I'm actually Swiss, but living more than 15 years south of Munich. And I'm responsible in the vertical marketing team for the smart industry market, supporting customers and the Avnet team in industrial and IoT solutions. I have more than 20 years of experience in semiconductor distribution and had several positions within Avnet, including Business Development Manager IoT. Let's have a look at the agenda for today. First, I will talk about challenges and opportunities in smart cities. Then I will go into AI and how AI can help in smart city applications. After that, I will speak about predictive analytics and condition monitoring and where and why it will be used. Then I will come to the main topic, the implementation of condition monitoring with the Raven IoT box. I will explain the system of the Raven IoT box, what is implemented, and where it can be used. I will also go over some use cases and pilot projects for the Raven IoT box. Then we will see a demo with the Raven IoT box in action. Finally, we will have time for questions and answers. Smart cities are like a clockwork with a lot of gear wheels that interlock with each other. If something fails, it can have a major impact on the whole city. More and more systems are connected to each other and to the cloud. Everything will be data-driven, and with the help of AI and ML, smart decisions can be taken and data-driven business models can be realized. Cybersecurity is key on every level, from the end node up to the cloud, and it needs to be implemented by design. In the mobility sector, we have a lot of new possibilities in smart cities. So electrical vehicles are connected to the grid. They're using energy, of course, but also they can be used as energy sources. This, of course, needs to be synchronized and over a cloud system, so they have to be connected. Also in smart buildings, we have a lot of opportunities to do optimization for energy, but also for a lot of other things. Now let's have a look into the technologies and applications for smart cities. Some years ago, the European Council announced the climate and energy goals for 2030. Reducing greenhouse gas emission to 40%, reducing energy consumption to 27%, and increase renewable energy share to 27%, all compared to the values of 1990. To achieve these goals, we need to, of course, implement new technologies in smart cities, like, for example, smart energy with solar and wind and hydropower directly produced on the buildings, for example, and inject this power to the smart grids, to the power grids, synchronize everything, so actually producing also some of the energy directly in the cities on the buildings. Another thing, for example, would be smart waste. Waste is, of course, in some cities a big problem. So the idea is to use less waste, of course, and recycle more. Directly in the cities, of course, the recycling can be done, or let's say around the cities, and also some new technologies like urban farming, directly on the roofs of buildings, or maybe also in special farming places inside the buildings, is a possibility to make cities more sustainable. Then, of course, the smart mobility sector is a very big, has some big challenges, but also a lot of opportunities. So like bike sharing, car sharing is used more and more. Also electric vehicles, of course, they actually using, of course, energy produced in the city, but also can be used as energy sources to deliver energy to the grid. And of course, all those applications, they all need to be synchronized with each other. And cloud and AI applications, of course, can help to do that. Also in buildings, there are a lot of opportunities to actually save energy. So let's say if nobody is in the building, then switching off the light, reducing temperatures, switch off climate controls, and only people are in the building actually. Switch on the lights and adjust the temperature to a level which is needed. Everything can be controlled, of course, with some mobile phones, and a lot of wireless connectivity is going on as well. Also street lighting with special sensors, so that only street lights actually can be dimmed if nobody is there, or if something has happened. Of course, the illuminance will be higher to have also the possibility to let's say have the safety which is needed for the people living there. So those are just some opportunities we have in smart cities. So everything will be connected, everything will be data driven. AI can actually help to implement that, but of course we need also some, let's say, condition monitoring to supervise everything and make everything work together. AI plays an essential role in smart cities by enhancing efficiency, sustainability, and the overall quality of life for residents. Resource and energy efficiency. AI can analyze vast amount of data to optimize resource allocation and energy usage in areas like traffic management, public transportation, and utilities, leading to cost savings and reduced environmental impact, and allowing for timely repairs and minimizing the risk of infrastructure failure. Also, traffic management is a good example. AI-based traffic monitoring and control systems help to minimize congestions, reduce commute times, and improve overall traffic flow, contributing to reduced fuel consumptions and lower emissions. AI-driven waste monitoring systems can optimize waste collections routes, reduce cost, and minimize environmental impact by collecting waste only when bins are full. Also in public transportation, AI can optimize routes and schedules, improving service reliability and reducing waiting times for commuters. Water management. AI can, of course, optimize water distribution, detect leaks, and improve water quality monitoring, ensure efficient use of this critical resource. Also, air quality is key for smart cities. AI can monitor the quality in real time, detect pollution sources, and provide timely alerts to residents and authorities. Also, public safety is, of course, crucial. So, AI analyze surveillance cameras and sensors to detect and respond to safety threats, accidents, and criminal activities. Then, of course, last but not least, early issue detection. Condition monitoring with AI allows for early detection of equipment or infrastructure failures, reducing the risk of critical failures and unplanned downtime in critical city systems like transportation, utilities, and public service. These are just a few examples where AI can actually support smart city applications. Why are we using artificial intelligence or machine learning? Actually, AI or ML can help to do different tasks in data analytics. For example, it's good for classification. So good or bad, dog or cat, roads with heavy traffic or no traffic. So actually classifying different kind of situations. It can also be used for regressions. So actually showing a trend or an outlook into the future. Also, clustering is a good field for AI. So having different kind of clusters of data sets. And of course, last but not least, anomaly detection is important. So actually detecting unusual things are happening. Let's have a look at predictive analytics for maintenance. So this slide actually shows the evolution of maintenance. So let's start with the reactive maintenance. So this means actually that the equipment will only be repaired if it has failed. Of course, this is not possible with all the equipments. So people want to use preventive maintenance. That means the equipment is actually maintained on a regular cycle to actually reduce the probability of failure. Then with condition monitoring, we actually have the possibility to do predictive maintenance. That means you can actually detect when the equipment is actually or will actually fail and do maintenance before it actually fails. To do that, of course, anomaly detection is a key point in a system. So actually identify rare activities into the system which are not normal and may lead to any failures in the future. To do an anomaly detection, mainly unsupervised learning algorithms are used, and together with predictive maintenance and supervised learning, you can actually really detect what's going on in the future. To even improve that, prescriptive maintenance is another step. So once the failure actually happened, it will be analyzed and the provided solution will be identified and the action to take to improve the outcome. So that means that you actually can see if a certain failure actually happens, what you have to do, and can actually do that, store that in a database, and also use the optimization of the improvement to do the maintenance. So those are the main steps in the maintenance evolution. And nowadays, of course, condition monitoring is widely used. Here's an overview of a condition monitoring system. So actually your asset, your device or machine, is monitored with sensors, and the sensors can actually detect vibration, acceleration, maybe sound, current, temperature, maybe has the possibility to use a camera to visualize certain events, certain defects. So all those sensors are actually used to monitor your device, and AI or ML algorithms either directly in the field on the sensor itself, on the machine, can be used. So actually you permanently monitoring the device, monitoring the health of the device, which of course leads into reduced downtime. All this data collected in the field will be sent to a cloud system, or maybe to a local server instead, where further analytics can be done. So using AI, ML, condition monitoring algorithms to actually use this data from this asset, but also combining that with other data from other sources to actually improve the prediction of any possible failure. Of course, you can also use this to do alarms, to do the visualization, so you can actually check in real time what the status of your device in the field is. And if, of course, something is unusual, then you can generate an alarm, and of course to take actions. So let's say you can actually stop the machine if something really urgent happens. And of course, if you do predictive maintenance, then you can also trigger an alarm to a service technicians who actually go to this asset and do a repair. Another possibility, of course, would be to monitor, let's say, the waste bins, for example, and as soon as they are filled to a certain level, this will generate an alarm to actually remove the waste from the bin. So with condition monitoring, you can actually improve the service and productivity of your city and reduce maintenance operating cost, and of course customer satisfaction will be increased. This actually leads to data-driven business models or service models like everything as a service, so let's say maintenance as a service, waste management as a service, energy optimization, water, heating, cooling, lighting, transportation, and so on. Coming back to the slides before, looking at condition monitoring use cases in smart cities. There are a lot of use cases where condition monitoring is needed and of course already used. So let's have a look at smart mobility. Of course, you can monitor the traffic in the streets and actually, for example, reroute public buses or maybe other cars to other roads if needed. Also, the charging of electric cars need to be monitored so that you can actually optimize your grid and the energy delivery to the grid. And also, if the grid needs some more energy, then of course electric vehicles can also be used as a source for energy. Also, the renewable energies need to be monitored. So if there is enough wind, if there is enough sunshine, and you're producing a lot of energy on the buildings, so that you can actually use that, for example, to charge cars. Also in smart buildings, there are a lot of use cases for condition monitoring. You need to monitor temperature, electric lights, and so on, to optimize the overall energy consumption of a building. So if nobody is there, for example, you can actually reduce turn off the lights and reduce the temperature, and so on. There are also a lot of smart sensors in the city to actually monitor streetlights, for example, to detect people and cars, and so on. Also, smart waste monitoring is a good example where you can actually monitor the waste bins, for example, and do optimized tours for waste collection. So without condition monitoring, you cannot run a city actually. So it's needed everywhere. Now let's introduce H&D Wireless and the Raven IoT box for condition monitoring. H&D Wireless is a Swedish, very innovative company for wireless and IoT. They provide wireless modules, IoT solutions like the Raven IoT box, SaaS solutions, and development services. Lord Kelvin said, To measure is to know. And if you cannot measure it, you cannot improve it. Those statements actually explain very well what condition monitoring is all about, and also the offer of HD and wireless. Griffin IoT, a system that measures anything, collects the data, sends it to the cloud, analyzes it, and with that you can actually reduce the maintenance cost with 30 to 50%. Another offering is the CHEPS system, which actually tracks moving objects, vehicles, and analyzes the movements. With that, you can actually reduce the search time by 90% and improve the asset utilization. This slide shows the H&D wireless IoT products connected to the Griffin cloud. It can be either finished products, so sensors with short range or short range and cellular radio integrated, but also it can be some radio modules connected to other systems or your own systems, or H&D Wireless can of course also do some sensor modules with radios integrated, customized to your needs. The Griffin Cloud actually connects all those systems, does the monitor and control algorithms, the analytics, statistics, can generate dashboards and alarms and everything. Of course, you will have REST APIs to integrate all the data in your own systems. Of course, dashboards and apps will be provided as well. Also, IoT services around that can be provided by H&D Wireless. Let's have a look at the Raven IoT sensor box. The sensor box will be placed on a device to monitor, for example, a motor. With the integrated sensors like temperature, accelerometer, magnetic field, GPS, it will actually measure the condition of the device. For example, the runtime of the motor, if it's switched on or off, vibration, which are not normal and could actually damage the motor. There are different kinds of profiles available for the box so that you can actually match the concrete application, for example, a pump profile. The data will then be communicated to a cloud system, the Griffin Cloud, or a cellular connection with either LTE or NB-IoT. Those two technologies are well suited for battery-driven applications and for low data rate. Avnet Silica offers a cellular connectivity service with global coverage, together with our partner Pix. Basically, we will provide UACC, a reprogrammable SIM or eSIM, which is placed into the device. And on top of that, we provide the global coverage service with Pix. So regardless where the device is installed, you will immediately get best cellular connectivity around the globe. Our solution makes you independent from operators, and it can be remotely reprogrammed with profiles from operators. After the data has been transmitted to the cloud, it will be analyzed either on a computer and visualized either on a computer or mobile app. The condition status is available live, and several KPIs can be measured, as well as actions can be triggered, like, for example, switch off the motor in case of an anomaly detected. Also, easy integration into customer cloud systems or IoT Connect, Avnet's cloud platform service, is possible. This slide shows the target markets for the Raven IoT box. So in smart city, for example, water treatment like fresh water, brown water, pump stations, and so on. A common use case in smart city are monitoring the pumps in water distribution. So you would actually put the Raven IoT sensor box on a pump loaded with the pump profile to monitor and detect any anomalies in the pump system. So you get all the data from the pump directly to your dashboard, either on a PC or on a mobile app. So it will show the runtime, the vibration, any kind of temperature, and so on. And depending on the KPIs you are defining, you can of course also trigger actions and alarms. Another use case are the monitoring of manholes in sewage systems. In a city in the Nordic, we are running a pilot with a water company. They like to monitor the manholes and pump systems. In the manholes of the wastewater systems, the water level, sound, and temperature are monitored to optimize the water flow. With a full deployment, over 20,000 manholes will be monitored. When it rains, the rainwater is coming to the wastewater system, which will costly impact the water treatment, what they actually like to avoid. With the supervision and monitoring, supplemental water coming to the system, like rainwater or water from other sources, can be detected. Also, leakage of the wastewater system can be found. Additionally, the pump stations will be monitored as well to detect anomalies which could actually damage the pump. With this IoT system, the water company will optimize the water treatment and reduce the environmental impact, and of course, overall save a lot of costs. This slide shows some images of the pumps equipped with the Raven IoT box, as well as a dashboard of the mobile app. Another use case is the monitoring of door drives to reduce maintenance costs, reduce unexpected damage, and increase the availability and customer satisfaction. It can be used on any door, for example, on warehouses, or doors for fire brigades, hospitals, or even on bus depots. This slide shows the customer engagement process of a Griffin IoT system, from pre-study to deployment. First of all, we start with a pre-study, discussing with all the stakeholders about the goals and outcomes and the KPIs. So basically defining everything which is necessary in the project. Then we go to a proof of concept, which takes a lot, depending on the application, 1 to 3 months. So actually validating of all the equipment installed and the achievement of the goals. After that, we start with a pilot, which typically runs 3 to 6 months. So a customized solution will be installed on the customer side, proving that all the goals can be achieved. Some additional trimmings for the commercial deployment will be made, and so on. After that, the real deployment will be started, and of course covered with the SLA, so the agreement, the service level agreement for all the services and application. Here I'm showing you a return of investment calculation from a real customer. So it's actually estimating the annual productivity gains and cost savings he has with the Griffin IoT system. So first of all, he will of course save money and improve the efficiency by the service staff around 50%. Predictive maintenance saving will be another saving, of course, and all the data which is stored in the cloud in a digital logbook will give him an additional savings. So with all those savings calculated together, he will save around 5 million euro per year, just with condition monitoring based system based on the Raven IoT box. The Raven IoT box is an easy-to-use system for condition monitoring, which can address a lot of use cases in smart city and other markets. And now it's time for demo. The video will show the capability of the Raven IoT box with a motor demo.
Hello, I'm Åke Jernberger. I'm CTO and VP of R&D at H&D Wireless. And today I'm going to show you how to use the Raven IoT Box 827 device together with IoT Connect from Avnet. You can easily adapt your device to do what you like with the app that we developed. So all you do is that you select to scan a device, you scan it, and you select what template you want to use and what name you want to give it. You can either choose a generic device that all the sensor data is sent up to IoT Connect, or as in this case, a smart edge device where it controls a pump. So for this case, we have a smart edge device, a pump control. I will just show, I will turn it on and the motor runs and everything is fine. It reaches its RPM and it's running smoothly. So what if the box then detects something is wrong? Well, what we do is that we add the balance weight, some magnets here. And we turn it on again. Now it's vibrating more heavily, and after a while the box detects the high vibration and shuts it down, sends a message and the data to IoT Connect, and you get out notifications to the service technicians and anyone that needs to know that the pump has stopped. So when the service technician gets the notifications, he goes to the pump, okay, finds the problem. Well, he can remove it or maybe then change the bearing or what's required. And in the app, he selects the device and send a reset and say everything is clear now. And we should see that shortly the pump can run again. Thank you from H&D Wireless.
Hopefully this video gave you an impression of the Raven IoT box and how it could be used in your next application or project. Raven IoT box is just one possible solution for condition monitoring for smart cities. We can provide many more solutions for your applications. We are providing a lot of services around IoT and smart city applications, like, for example, embedded hardware solutions with SOMs, carrier boards, single board computers, displays, HMIs, so either complete solutions or customized solutions, which can be easily, of course, implemented in your project. And of course, the cellular connectivity services, as I just mentioned some slides before, with UICC, cellular modems and gateways and everything around connectivity. Then we can also provide IoT services, IoT Connect as a platform as a service, for example, integration into IoT Connect based on Microsoft and AWS cloud services. Additionally, as I mentioned in the beginning of the presentation, security is really key. And there we can, of course, provide either secure elements, secure MCUs, MPUs, but also cloud services, as well as secure device programming and provisioning. And on top of that, the software and services we can actually provide, let's say, software for embedded devices, but also for cloud services. This slide shows the journey from devices to insights, and also that Avnet is your one-stop shop for your projects. So starting on the left side, design building blocks you need to design your devices. Then, of course, building the devices, build gateways, connect to gateways to a cloud platform, generate insights using AI and other data, and of course, create value. All this is, of course, secured. So Avnet Silicon Avnet can actually provide you building blocks, silicon you need to build your devices. With Avnet Embedded, we can also support you on a hardware design, software design, build your devices. For the gateways, we can provide Teltonika, Miromico, and as well services, connectivity services like, for example, with BICS, to connect your devices to a cloud platform where you can use IoT Connect, our platform as a service running on Azure and AWS. From the software side, Videkio can actually provide you device software, and SoftWeb Solutions can provide you cloud software, so that you can actually use your devices together with software from Videkio and SoftWeb Solutions and complete the full chain from devices to insights. Everything, of course, as I mentioned, is secured, for example, with secure elements and secure MCUs, but also with the secure device management services, so securely provisioning your devices. I would say this is a really unique end-to-end advantage you get with Avnet. If you'd like to know more what's going on in IoT and looking for new ideas, I can recommend you our We Talk IoT business podcast. I'd like to summarize my presentation. With permanent monitoring of the device health status gives you live insights about the asset in the field. If something happens, immediate action can be taken. So condition monitoring is key for the most smart city applications. It will reduce downtime, increase productivity, extend product lifecycle, reduce maintenance cost, saves money, and increases the sustainability of your application. With the Raven IoT box, an easy-to-use solution is provided for your smart city project. Thanks a lot for listening. And now it's time to ask questions.
All right, thanks everybody. We've got Gabriel here live with us to do some Q&A. So thanks Gabriel for joining us live today. We're so happy to have you. We have a couple of questions that have come in, so we'll go through and ask some of those. So the first one was, will urban architecture or agricultural be part of smart cities? So how can condition monitoring be used in urban agriculture? I keep saying the wrong word.
So thank you for this question. Of course, it can be used in any agricultural application, even if it's urban or any other kind of applications, agricultural applications, because you need to monitor a lot of things in agriculture anyway. So, for example, detecting the moisture of the ground, when to watering the plants, for example, and all those kind of things you can actually monitor and build rules when to water the plants, when to fertilize the plants, and so on. So there are a lot of things you can do in agriculture.
Great, thank you. Are the rules to detect the anomaly just demonstrated in the demo procedural or description? How are the rules modified?
Okay. It's actually a mixture. So the rules are actually defined by the different profiles. So there are different profiles, for example, for pump or motors or whatever. And also it depends on the application, of course, what kind of sensors you actually, sensor data you want to monitor. And to modify the rules and how this is set up can be done together with HMD Wireless. So they have different kind of profiles. They have rules available, and you can actually together with also with them define what your application needs.
Great. One of the other questions we got was, what kind of products does Avnet have for IoT market? Can you name some?
Sorry, what products?
Yeah, what kind of products does Avnet have for the IoT market? Can you name some products that Avnet has for that?
Yeah, of course, the Raven box is one of them. But we have a lot of other modules, so let's say silicon products, wireless modules, for example, which are needed for any kind of IoT application anyway. But to have, let's say, finished products, we don't have so much finished products, more on the gateway side, but not on the, let's say, module or end product side. But we have building blocks actually that you can build your own sensor with wireless modules, LoRa modules, and so on, which then are connected to a gateway, of course.
All right.
But just let us know what you want to do, and then we can help you.
Great. Let's see here. Let's see what other questions we have. How is the Raven IoT box powered?
Okay, the Raven IoT box is powered by battery, so it's a rechargeable battery included. You can also power it over the USB-C port. There's a USB-C port integrated, so either to charge the battery or recharge the battery, or of course, if you want to power it from a power supply, you can also use this port as well. There are some other options you can use using energy harvesting. So like either with solar cells or maybe with vibration, but those are additional options, and you have to actually integrate that into the box, or either have an external box and connect it to the USB-C box. But this is possible as well.
Thank you. Is the box based on Nordics chips?
Yes, they are based on Nordics chips, yes.
Awesome.
Yeah, that's true.
Okay. Which sensors are included?
So there's a temperature sensor included, accelerometer, where you can also detect shocks or movements and so on, and also build some rules on that. There is a magnetometer inside, so that you can actually measure magnetic fields, and also e-compass, for example, is integrated so that you can see the position of the device. Of course, GPS functionality is integrated because of the Nordic chips we're using there. And just the light was switched off, sorry. Yeah, those are basically the main sensors integrated. If you need some other sensors in your application, then it's also possible to add them to I2C bus, or we can actually build custom modules as well.
Great. What kind of profiles are available?
So the profiles, the most common ones we are using are a pump profile for motors, fans. So the basic ones. There are some other ones available as well, or some ones just right now in development. So, but this also depends on the application and then the need for those applications. But those three ones are the most used at the moment with this box. But if you have a certain use case, we can also adjust the profiles and make some custom profiles.
Great. Is any price available? What's the price?
The price, good question. I think it's for the box, it should be somewhere between 150 euros, something like that. Something, yes.
Yeah, we'll see if we can find the link to that too and
Yeah,
share with all of you. All right, great. This person said, I couldn't find Gerber files for Z board from Avnet. Will Avnet publish PCB Gerber files for its IoT board in the future?
Probably not for this.
I think maybe.
Applications, yeah.
Sorry, can you repeat that? I think you cut out just slightly a little there.
It's not made, let's say, in our IP, let's say, and of course you can have the Gerbers, but then we have to do some license stuff around that so that you can use that. Yeah.
Okay. Does Avnet provide design services to prototype PCBs based on component and sensor selection?
Yes, we can do that. We can do PCB solutions. Yeah, of course, we have to discuss about the volumes and what you actually need. Yeah, but yes, that's possible.
Awesome. Another question, remote installation. What are the communication methods available?
Okay, so the communication methods we are using is cellular connectivity. So either LTM or LTM connectivity or NB-IoT. Another possibility would be Bluetooth connection as well.
Great. All right. Well, I think that's all the questions that we have. Thank you, Gabriel, for coming on for a live Q&A and for your presentation. Thanks, everyone.
Thank you. Bye.